All right, we're still graphing linear inequalities in two variables, and we are on example 4, solving real life problems. So you can spend at most $10 on grapes and apples for a fruit salad. Grapes cost $2.50 per pound, and apples cost $1 per pound. Write and graph an inequality that represents the amount of grapes and apples you can buy. Identify and interpret two solutions of the inequality. All right, so the first thing is we kind of got to understand what we're looking at. So if it says you can spend at most $10, at most would be less than or equal to $10. So you know that your inequality sign is going to be less than or equal to. And that's because at most means you probably got a $10 bill and you have to stay within that budget, okay? And you're going to be buying grapes and apples. All right, so grapes cost $2.50 per pound. So we could say let X be pounds of grapes. Let's go ahead and define our variables. And apples cost $1 per pound. So we can say let Y equal pounds of apples. All right, so that just lets us know that when we're talking about X, we're talking about grapes, Y, we're talking about apples. So you can spend at most, so that's less than or equal to $10 on grapes and apples for a fruit salad. Grapes cost $2.50 per pound and apples cost $1 per pound. Write and graph an inequality that represents the amount of grapes and apples you can buy. All right, so it gives us $2.50 per pound. So we're going to do $2.50 per pound of grapes. Remember we said X equals your pound of grapes. So 250X represents that part of the inequality. And then we're going to say plus, and we're going to add because we have $10 to spend on grapes and apples. So that means combined. So that's why we're going to add. And then we have apples cost $1 per pound. So we're going to have $1 times Y, because Y represents our pounds of apples. And that's going to be less than or equal to the amount of money we have to spend, which is $10. All right, so the first thing you have to do is kind of make sense of the problem, and you just have to read it, and then once you define your variables, hopefully it'll be easy to plug that in and set it up. All right, so it says to write and graph an inequality. All right, so we have wrote an inequality. Now we need to graph it. Since this has one Y, that's the same as just Y. So I'm going to quickly put this in slope-intercept form by subtracting 250X from both sides. So we're going to have Y, or 1Y, less than or equal to negative 250X. And then the $10 is still there. So we're not going to move that. So all we did was subtract this $2.50 times X to the other side of the inequality. So now we have Y less than or equal to mx plus b. That gives us our slope and our y-intercept, so it makes it easy to graph. So if b is our y-intercept, that means 10 is our y-intercept. So I only have a graph here that's in quadrant 1. Having negative numbers for pounds of grapes and apples is not going to be applicable in this case, so it wouldn't make sense. So we're not going to use anything but quadrant 1. So let's graph our y-intercept at 10. So I'm going to have a point here. And then my slope is negative 250x. So down 2.5 over 1. Down 2.5 over 1. And you can continue to do that until you get to the x-axis, which would be at 4, 0. All right, this says less than, so I'm going to use the less than is going to be, well, no, we got less than or equal to, so we're going to use a solid line here. And then our solution would be all of the points that are in here. Now remember, X represents the pounds of grapes, and Y represents the pounds of apples that we are talking about. All right, so if we choose a point inside the shaded region, all right, let's choose 1, 6. I'm just picking a point inside the shaded region here. All right, so 1, 6, you can see falls in that shaded region, so that would be one solution. It says identify and interpret two solutions of the inequality. So 1, 6 would represent having 1 pound of grapes and 6 pounds of apples for less than or equal to $10. So that would be one solution for your fruit salad. You could get 1 pound of grapes and 6 pounds of apples. Another solution, we could go here on the boundary line. Because it's a solid line, that means the points on the boundary line are included. So we could have 2 pounds of grapes and 5 pounds of apples. All right, so that would be two solutions that we could use. So 1, 6 and 2, 5. You can see that any of the points inside the shaded region would be solutions of that set, but choosing whole pounds is what I did in these two cases. But you could buy half a pound of grapes, but anyways, that's anything inside this boundary line or anything inside the shaded region below the boundary line would be solutions for this inequality. All right, you also can check to see if this works. Okay, this is your X, this is your Y. If you plug it in, 1 times 250 would be 250 plus 1 times 6 is 6. 250 plus 6 would be 850. Is 850 less than or equal to 10? Yes, so that would check to see that that is a solution for the inequality. All right, if you have any questions, please let me know.